Hello everybody. Today we'll be going over population survivorship curves and hypothesis testing. First, for this lab, we're going to consider these few questions. 1. When was the Industrial Revolution? In America, that happened in the late 19th century and the early 20th century. So right before our first time period that we look at. When were antibiotics discovered? The discovery of penicillin was in 1928. This is during the first period we're looking at. However, it wouldn't be commonly used until after our period. When did C-sections become routine? C-sections became routine around the 1940s, which again is right before our second time period. So how would female pregnancy impact survivorship? You could think about the relationship between C-sections, how they weren't common in the first half, but they were in the second half. Survivorship on pregnancies increased over time. So a long time ago, whenever you were pregnant, often you did not make it through the labor. So why might male lives be shorter than female lives? And this is going into the second question right there, which is any wars going on during these time periods. The first time period we're looking at includes World War I. And the second time period we look at includes the Vietnamese War. So what is your predictions about how age at death will differ between males and females and between our two time periods? So you answer this on question 1 of the assignment. And that again relates to the questions right here. So we looked before at step 1, step 2, and step 3. We will also today be doing step 4. So running t-tests, ANOVAs, correlations, or regressions. We're not doing all of them today. We're picking a particular one and then conducting that one. So going over null hypotheses again, which means no effect. So the null hypothesis of this would be there's no effect between males and females of ages and no effect between times. So the HO is no effect. HA is the alternative hypothesis, which means there is an effect. And again, to accept the null hypothesis, your p-value needs to be more than 0.05. So what is a p-value? Probability that the differences you observe would occur if there is no actual difference in your populations. So, i.e., this means that your populations were equal. So, can you confidently reject the null hypothesis? If p is less than 0.05, that means there's a 5% chance that a pattern is a result of chance differences and not a pattern they're driven by changing variables. So you can reject the null and conclude the alternative hypothesis if the p-value is less than 5%. So on a graph, you can look at the graph right here and see that the p-value is more than 95% of the threshold. So your likely observation hill has already since passed, and any unlikely observations are likely to be explained through actual variable differences. So here's the practice. You're testing the hypothesis that adding fertilizer affects plants' heights. What's your null hypothesis? What's your alternative hypothesis? The p-value you receive is 0.1. So should you accept or reject this null hypothesis? I'll give you a minute. You would accept the null hypothesis as the p-value is more than 0.05. So there's types of variables. You have discrete or nominal variables, so it's categories such as male or female. You have continuous variables, such as numerical values, as temperature. And there's ordinal, so ranks, so like placeholders, so place 1, place 2, place 3. So which do I use for each test? Today we'll be looking at the t-tests, because we're looking at between groups. We have males and females, and we have 2 different time periods. How many groups do I have? We're looking at 2 tests at a time, so we're looking at males, females for one, and then we're performing another test to look at males, females of another. So we're performing a t-test.